Hello everyone. Today in this lecture we will learning about dimension reduction. Dimension reduction are techniques specifically focusing on identifying multicollinearity and applying principal components analysis PCA in Python. These methods help us uncover meaningful patterns and create simpler, more manageable data sets for analysis and modeling. Identifying multicollinearity. First, let's see what is multicollinearity. Multicollinearity basically is a situation where multiple independent variables are correlated with each other in a regression model. What is the actual problem of multicollinearity? It occurs when independent variables in a dataset are highly correlated, causing instability in statistical models. Their correlation basically creates some instability. The statistical models are unstable because of these correlations. What can be the solution of this situation? We can detect multicollinearity using techniques like variance inflation factors VIF or correlation matrices. These tools helps us to identify that what are the variables these that are highly correlated. Now, how to apply the principal component analysis, that is PCA. First method is to standardize the data. Ensure all variables have similar scales to avoid bias in PCA. Second method is to compute covariance matrix. This matrix captures the relationships between the variables. Third method is to calculate eigenvector and eigenvalues. Eigen represents principal components while eigenvalues indicates their importance. And the fourth most important technique is to select principal components. Choose components that explains a significant proportion of the total variance in the data. Moving forward is to how to interpret PCA results. In the previous slide, we have learned how to analyze or apply PCA, and now we are looking forward to interpret the PCA results. First technique is through eigenvectors. Reveal how original variable contribute to each principal components, providing insights into an underlying structure of the data. Second is through the eigenvalues. Indicate the variance explained by each principal component, helping prioritize the most important ones. And third is by screen plot. Visualizations of the eigenvalue, adding in the selecting the optimal number of principal components. Now let's see how to select the optimal principal components. First method is to choose the commutative variance. This is basically a variance that assesses the proportion of total variance explained by the selected components. The second method is to select the screen plot. Now, the screen plot is to look for an elbow in the plot. An elbow is the um, an elbow is basically a sign of where the rate of change in explained variance. Third method is to find the Kaiser Cartesian. The Kaiser Cartesian selects components with eigenvalues greater than 1 and suggesting that they explain more variance than a single original variable. Now see what is PCA in predictive modeling. Feature reduction. PCA simplifies the data by reducing dimensionality, which can improve model performance and prevent overfitting. PCA basically reduces the features of and dimensionality in the uh, model, which can improve the performance by preventing overfitting of any variable in the model. Interpretability. PCA can help identify the most influential factors in the data, making it easier to interpret model results. And its efficiency is the third predictive modeling technique. Using fewer features can speed up modeling and reduce compatuate बाप रे बाप, कम बोला ही नहीं. Efficiency. Using fewer features can speed up model training and reduce complexity. You can see we are in the VS Code IDE and I have imported pandas at PDS package from sklearn.decomposition and imported PCA, sklearn.preprocessing imported standard scalar and matplotlib as PLT. Now, as usual, we have created a data frame for PCA. Data equals to PD dot data frame, passing the parameters feature 1, 2, and 3 along with its values. Standardize the data. Important for PCA. We have to first standardize the data using scalar equals to standard scalar function and scaled data equals to scalar dot fit underscore transform, passing the parameter data into the function. Now moving on, we have to apply PCA. For applying PCA, we use PCA equals to PCA, applying the components in the parameter. Third step is to create a data frame with the principal components PCA underscore data frame. For data frame, we have used df here equals to pd dot data frame, passing the parameter data and respective columns. How to visualize the result? We use different functions like plt.figure, plt.scatter, plt.title, label x, y, and then finally using the plt.show function to show all the results. That being said, the concept of dimension reduction is completed. Up until the next video, we'll meet. Thank you.